name is Dr. Petros Aristidou, and this is a small introductory video to the dynamic simulator RAMSES. You can find the simulator and information about the scientific background behind it on the website of Professor Thierry Van Cutsem. You can see the link here, and you can find it also in the description. On this website you can find a small introductory presentation about RAMSES. You can find the simulator itself, at least a limited version of the simulator, as well as installation guidelines, how to install and first use the simulator, and what you need to know before you start running some simulations. Finally, there are two example test systems, a small 5-bus system and the well-known Nordic test system that can get you started. So what I have done in this tutorial, I have downloaded the limited version of the simulator available here, as well as the Nordic test system that you can see is the zip file here, onto my computer, and I will show you how to run one simulation. So you can see here the two files, and I will unzip the Nordic here, the Nordic data. So if I open this, you can see a lot of files. We will explain a little bit what is everything. And you can also see the simulator here. So first thing you do is that you double click on the simulator. If nothing happens, then it means that probably you don't have Java installed. In order to make sure that you have Java installed, you can open a command line window, and you can write Java -version. Then you should see something like that. If you don't, then it means that you don't have Java installed, and you should follow the information on the website of Professor Van Cutsem in order to get Java installed. Now, this is the GUI of the simulator. You can see here there are several tabs. I'm going to briefly explain what each one of these is for. The first tab says System Data. What you do here is that you load all the data. That means the information about the network, plus all the dynamics and the controllers of the components attached to the network. And here you can load the disturbance file, meaning that is a file that describes the disturbance that we want to simulate. When you have the solver parameters, through this tab you can modify some of the parameters of the simulator. I would suggest that you don't do that for the moment. Then you have the observables tab. These are split into runtime observables, so this is what we see during the simulation. And this is the observable file, which includes the observables that we will have access to only after the simulation. So after the simulation finishes, we can read and all the variables that are in the system, and we can extract some curves. Then we have the simulation pane, so you can see here during the simulation you will see here all the comments and all the information about the simulation, if it is successful, or which version of the simulator we're using. As you can see here, the only button that is available for the moment is Simulate. And finally we have the Analysis tab. So here you can post-process the simulation results and extract some curves. So these can be voltages in the system, currents, powers, or some variables of synchronous machine or any other component attached to the grid. So the first thing that we do is that we click on Load Configuration. We go into our folder with the data, and I'm going to load the second one, which says Simulate a Short Trip. So once you load this, you will see here these lines have been pre-populated. However, you will see that they refer to some locations that do not exist on your computer. So what you need to do is you need to go to each one of these files and find the location on your system where you have unzipped these and select them again. So I will go, for example, here is dim.a.dat. I go load file, and I go into the folder that I unzipped and I select dim.a.dat. You will see here that the location has changed. I do the same thing for all of the others. Here we go. Finally, we're short trip branch. And also there is another file in the observables. You will see it here, observable files. I select ops.dat. Now that we're done, we can save the configuration file and overwrite the one that came in the zip file, and that way it will keep the locations relevant to our computer and not the ones that we downloaded. So next time we want to run again this simulation, what we can do is just click File, Load Configuration, select this configuration that we just saved, and it will have the links relevant to our computer. Now that we have here all the system data, we have the disturbance, then here we have the runtime observable, so we will be monitoring the bus voltage on transmission bus 1041, and also we have a list of observables of variables that we will save for post-processing. We can start a simulation, so we go into simulation and we click on simulate. Okay. So here we see the voltage magnitude on bus 1041. So you will see a very nice long-term voltage collapse scenario. You can see all the details about that in the relevant report, in the relevant Nordic system report. Okay, now I close this. Here, as I described previously, you can find descriptions, so you can see here which version of RAMSES you're using. There is a disclaimer here. Then you can find information about the solver settings, the events that happened in the simulation. This is a debugging output, so it shows you how much time was spent on each of, let's say, the relevant simulation parts, etc. Then we can go into the analysis. You can see here that these buttons have become activated. I can click on extract curves, and here we can extract anything we want from the simulation. So we can go into synchronous machine, for example. I want to see what happened with synchronous machine G18, and from there I want to see the rotor speed. I confirm the selection, and that's the only thing I want to see. So then you can press preview curve, and here shows you the rotor speed of machine G18. You can select several curves on the same plot. For example, I can select G3 and I check the rotor speed. I confirm the selection, and then I want also G8. Again, I want the rotor speed. I confirm the selection, stop selecting, and preview curve. So we can see both of the curves on the same preview. Okay, here they are. Can zoom in and see the difference between the two. So what we can do after we extracted the curves, we can save them for post-processing. Once we're done with the simulation, what we can do is close. If you have any open curves that you want to keep, then you press yes. If you want to also close all the previews, all the curves that you have open, then you press yes and clear all open windows. If you want to uninstall RAMSES, then the only thing you need to do is select all of these folders and files and just delete them. So that's it for now. I expect to have some more tutorials in the future explaining in more detail some of the functionality of RAMSES. Thank you very much and have a nice day.